Hi, so this is our presentation for ECEN 361 Embedded Systems and 480 Digital Signal Processing. What you see in front of you is the Hexcopter Aerial Photography and Agriculture System. It is a 6-rotor multi-copter built for the purpose of helping ranchers and farmers better manage their land.
Okay, so our first goal when we did this was basically to get it up in the air and make sure that we could fly it. So we did that using this remote here, where we programmed it so that we could change the flight modes based on the switches on this remote between just some different stuff such as land, stabilize mode, altitude hold, which just goes to a certain altitude and stays there, and so on and so forth. And then we use this lovely TV on the top of the remote, and it connects to the camera at the front of the Hexcopter, allowing us a first-person view of the flight.
So our next goal was to be able to fly it completely autonomously without the remote. Flying it with the remote is pretty fun, but it better fit our goals to be able to fly it autonomously. Now what we used was a tablet like this connected with a telemetry antenna, and we used an app called a tower that connected to the Hexcopter, and we were able to plan, we call them missions, with different waypoints, and the copter would follow them using the GPS coordinates.
So once we were able to achieve autonomous flight and to fly a set pattern repeatedly, our next goal was to actually make this useful to farmers. And what we did to implement that was to use something called NDVI, that's Normalized Difference Vegetation Index. And what that essentially means is that we take pictures with a modified camera, and that gathers light in both the infrared and visible spectrums, and then compare the ratios of visible to infrared light, and that will actually tell us the health of the plant in correlation to the amount of chlorophyll in those plants. And that allows the farmers to predict trends in their fields and to be able to figure out what they need to do to make their fields healthier.
So in order to take those NDVI pictures, we took a standard Canon point-and-shoot camera, and we removed the infrared filter and put in a filter that would filter out the red visible light, and that's how we could run the algorithm that Jared has explained. So we also had to load a special firmware on the Canon camera called CHDK, which would allow us to remotely trigger the camera and be able to geo-reference our pictures.